Hello, everyone. It's a pleasure to be here today with you. My name is Douglas Lima. I am a DevOps consultant with AWS Professional Services. I have been working with a great number of game customers, and most of them are looking for modern solutions. For those that doesn't know what is professional services, we are a consulting organization inside AWS. At AWS Professional Services, we know that adopting the AWS cloud can provide you with sustainable business advantages, and supplementing your team with specialized skills and experience can help you achieve those goals. This presentation is based on an engagement between us as professional services team and one major AAA studio. This specific customer is a global market leader in MMORPG and also FPS games, so probably you heard about them. But sadly, I can't say the name. This is the agenda for this presentation. I will start with the solution overview. After that, CDK overview. I also want to discuss Amazon Glue and Amazon Kinesis and finish with the implementation and the results we had. I would like to start talking about the solution and give you a brief explanation of the customer pain points. So, what were the requirements of this customer? First, they needed a high scalable solution. They were not using AWS Cloud, and their cloud provider implementation was not able to provide consistent low latency and throughput. They were based on vertical scaling strategy, which caused unexpected surge of infrastructure cost and long scaling time. Second, they were looking for a content-based solution. Their cloud provider was not flexible enough to provide dynamic routing of message for new subscribers without code changes for every deployment. They needed a content-based architecture that could dynamically identify the content of the message and route that to the different subscribers. Third, they wanted a serverless solution. That's because another pain point was related to the customer lacking resources of managing Kafka clusters, and they want to reduce maintenance overhead. For that, they were looking for a serverless solution. In fourth, reusable. Due to their global impact, they requested a fast deployment process with reusable code. To achieve these goals, we proposed the following high-level architecture. We start from the data ingestion app that will read all message from the streaming data source as provided by the customer and publish it into the Uber stream. The Uber stream will store all ingested whole message for processing. In this layer, a telemetry subscription service will augment message with schema or attributes from in-memory data store as provided by the customer and will push them to the router stream. The router stream will store augmented message for routing. Here, we have router lambdas that will consume message from the router stream, implementing dynamic routing logic based on the message attributes, and will send message to the target subscriber streams. The subscriber streams will be dynamically provisioned and will store messages destined to a specific subscriber. One or more streams can be provisioned per subscriber. In the application layer, we have an API gateway that will provide a REST API for deployment of subscriber streams, which will invoke the subscriber deployment app to provision resources. The subscriber deployment app will provision new subscriber streams with respective routes based on the message content. To monitor all the solutions, we have CloudWatch to collect AWS-specific operational metrics such health, throughput, and so on. Now, let's see how AWS services fits into the customer's requirements. To fulfill our customer requirements and help with their pain points, we choose the following AWS services and solutions. For high scalability, we have Amazon Kinesis. For high scalability, we have Amazon Kinesis, and also for serverless, we have AWS Glue and Amazon Kinesis. For content-based and reusable requirements, we choose Aws Cdk. So let's take a look in each one of them. Beginning with Aws Cdk. The AWS Cloud Development Kit is an open source software development framework to define your cloud application resources using familiar programming languages. Aws Cdk uses the familiarity and expressive power of programming languages for modeling your application in the cloud. It provides high-level components called constructs that pre-configure cloud resources with proven results, so you can build cloud applications with ease. Aws Cdk provisions your resources in a safe, repeatable manner through AWS CloudFormation. It also allows you to compose and share your own custom constructs, incorporating your organization's requirements, helping your expedition of your new projects. Besides all of that, the usage of CDK contributes to operation excellence and reliability. In simple words, the CDK benefits are easier cloud onboarding, faster deployment process, customizable and shareable infrastructure deployment. Usually, customers ask, what are the differences and similarities between CDK and Terraform? Because Terraform is very popular as an infrastructure, as a code tool. So let's take a look at that. First of all, language. Terraform uses a JSON-like language to define resource and the other data, the HCL, or HashiCorp configuration language. On the other hand, we have CDK, and CDK is a cloud formation wrapper that allows us to define your resources in different programming languages. Both Terraform and CDK codes are very simple. However, for big projects, Terraform has a drawback. As simple as Terraform is, it is, a new language, and we'll need to train your developers in a whole new language that is not familiar to the other programming languages in use. More importantly, data manipulation in Terraform is not as simple as is in other programming languages. For example, iterate through lists and objects, and transforming values is not as simple, especially for beginners. Modularity. Both can be used to build models. Terraform has a registry for privacy models or public models, and CDK can create reusable classes, functions, and even constructs. State management. Terraform generates a state file. It can be stored in a remote backend like S3. The CDK, as a cloud formation wrapper, does not generate a state file. As it is a managed service, it does the state checks in the background, so you don't need to worry about state files using CDK. In both, you can know the changes that are going to be made. In Terraform, you have the Terraform plane, and in CDK, you have a synthesized CDK. Logging and rollbacks both have logging capabilities. Regarding rollbacks, the CDK with CloudFormation behind will perform the rollback in case of failure of a change in the stack. Terraform does not have a rollback automatically. Control and governance. Basically, all access to AWS console is controlled by IAM. You can use IAM policies with AWS CDK and Terraform to allow or and deny certain actions. Scope. Terraform can create multi-cloud resources. The CDK is more AWS-oriented. However, it already has support for Terraform and Kubernetes. With that, let's see our next core technology. The second technology is Amazon Glue. Amazon Glue starts with Amazon S3. Customers have been building data lakes on S3 longer than any other cloud provider, and today, more data lakes run on AWS than anywhere else, and using Athena, an interactive query service to analyze all their data. In addition to the data lake, customers use a combination of our purpose-built database and analytic services like EMR, Amazon Elasticsearch Service, and Redshift to ensure they are using the right tool to the job, get to high performance, and scale at the lowest possible cost. To move their data between these systems, they use AWS Glue, our serverless data integration services. And finally, they use AWS Lake Formation to manage the security and governance of all their data, regardless of whether it sits in a data lake or in a purpose-built stores. And in all of these cases, we've invested heavily in offering the best price performance out there. Now, let's take a look on the last core service. Amazon Kinesis make it easy to collect, process, and analyze real-time streaming data so you can get timely insights and react quickly to new information. Amazon Kinesis offers a variety of capabilities. Let's take a look at them. First, we have Kinesis Data Stream, a massive, scalable, and durable real-time data stream services. KDS can continuously capture gigabytes of data per second from hundreds of thousands of sources, such as website click streams, database, event streams, financial transactions, social media feeds, IT logs, and location tracking devices. The data collected is available in milliseconds to enable real-time analytics, use cases such as real-time dashboards, real-time anomaly detections, dynamic pricing, and more. We also have Kinesis Data Analytics, the easiest way to analyze streaming data, gain actionable insights, and respond to your business and customer needs in real time. You can build sophisticated applications using Apache Flink, an open source framework and engine for processing data streams. Your application can transform and analyze data in real time and integrate with other AWS services. You can also use an interactive SQL editor to easily query streams, data, and build streams application. Simply point to a streaming data source like Amazon Kinesis data stream and use standard SQL to analyze your data in real time. We also have Kinesis video streams. It makes it easy to securely stream videos from connected devices to AWS for analytics, machine learning, playback, and other processing. It durably stores, encrypts, and indexes data into your streams and allows you to access your data through an easy-to-use APIs. And we have Kinesis Data Firehose, the easiest way to reliably load streaming data into data lakes, data store, and analytics tools. It can capture, transform, and load streaming data into Amazon S3, Amazon Redshift, Amazon Elastic, Search Service, and Splunk, enabling near real-time analytics with existing business intelligence tools and dashboards you are already using today. With all of that, let's dive deep into our implementation. From now on, I will show the code and the deployment strategy. To implement the solution, we choose a GitOps approach, where we have the Git repository as our source of truth. The full life cycle of the deployment is based on a CI/CD pipeline. The automated CI/CD pipelines control the infrastructure resources provisioning, the message converter deployment, and the subscription services and the routing services creation. Let's check how it is for the developers, like the developers' workflow. Developers works with a traditional Git flow approach. They submit their code to a feature branch that runs continuous integration steps. After CDK synthesize and validate the code, it starts the deployment process in the AWS account. To start work with CDK, first, you need to bootstrap the target AWS account. I will show you later how you can do that. Bootstrapping is the process of provisioning resources for the AWS CDK before you can deploy AWS CDK apps into an AWS environment. Simply run this bootstrap command, providing the profile account. So you can do a CDK bootstrap and point to the profile you are using. It will simply run everything you need to start working with your CDK application. After bootstrap, you can create your project structure using CDK init command, defining the language you want to use. Right now, CDK supports 5 programming languages, including Python, TypeScript, and JavaScript. For this solution, we created 3 core repositories. Each one of them is responsible for one aspect of the solution. Here is a simple code block where we implement the creation of a repository using TypeScript CDK construct. It's pretty simple. With 2 lines of code, you can create your repository into a code commit repository. This is a more complex CDK implementation. First, we define a build spec with the bash commands that run during each deployment. Then we run a CDK deploy command, passing the stack we want to execute automatically. All the implementations flow are controlled by a CDK pipeline method that deals with the interdependence between the resources. Here, we have each step definition and the implementation of a SNS topic to alert the team of a new deployment. Again, this code shows the build specification step, in this case for the infrastructure resources. As I mentioned, the infrastructure is created automatically based on the subscriber requests. To accomplish that, we remove the approval for CDK deploy. So here, we removed the approval, put in a require approval, never. In this code implementation, we are building the Lambda function based on the code changes in the Lambda template. So here we have the Lambda function call. And to do that, we run a CDK synth that will create a Lambda stack output, and we can reuse that output, in that case this YAML file, during the build time. Okay, before I move to the results, I want to show some code and some live demonstrations. Let's take a look at that. Well, let's start creating our project. I will create my game. So I go to my game. And as I said, we need to first create our application. And to create the structure of a CDK application, it's really simple. We just need to do a CDK, init, app, and language. We choose any language you like. In my case, I will put type script. Sorry, I forgot the T. It did not allow me to finish because I need to put the right word. Script type is okay. I did wrong. Okay. I just did that. This is crazy, right? What? Okay, let's CDK init app. Ah! Okay, I forgot the. So, as I was mentioning, it's pretty simple. We just need to choose the programming language you want to use. Just a reminder, CDK is built using TypeScript. If you want to contribute with CDK, you can use TypeScript for that. So, my project was created, as you can see here. There is all the files inside this project. With my project, I can now bootstrap my account. I already prepared an AWS account for that. I hope it works. So let's take a look at that. It takes time. It's looking to the internet, doing the stuff. Okay, it's already bootstrapped. So it was bootstrapped with no change. Here it's showing my AWS ID, my account ID, and the region I'm using to do that deployment. So now let's take a look on the code. I'll also show you the code of the implementation, not only this simple code. Okay, let's make it bigger. Here it's a simple CDK. It's the first structure that you have after you run your CDK init. You have these files inside your project. Let me explain you what they are doing here. First of all, we have the library. The library, here we put our stacks. What are the stacks? Stacks are the implementation, the resources you want to provisioning. For example, let's say you need to provision an S3 bucket. You can create a stack, and this stack, like a class, you will pass all the informations of your S3 bucket. So these stacks are like classes, and you can call these classes during your application implementation. And here in this binary, you have your application itself. This will be the place you put all the stacks you want to provision, all the stacks you want to create, like all the resources you want to create. So as I said, this is the simple application for CDK. But now let me show you the real code for the solution I just presented to you. Okay. This is the full solution I'm showing here. I will not show you the lambdas in this presentation, but I will show everything else. First of all, we have the CI/CD pipelines. As I mentioned, the customers, they wanted something that could be faster and automatically deployed. So we have here a CI/CD pipeline that controls all the workflow, all the pipelines that are responsible to create the resources. So here in this repository, we have each one of these pipelines. They are controlling specific parts of the project. So we have a pipelines for pipelines. We have a pipeline for routing lambdas, and we also have pipelines for infrastructure. As I mentioned, we don't need to care about AWS account. We are working with a GitOps approach, so you just need to put your code on the repository, and the lambda in the pipeline itself will be triggered, and all the resources will be created during the execution, during the request from the subscribers. So let me show you. Let me do this here. Okay. Here, it is a code pipeline. It's a CDK pipeline. A CDK pipeline is a way to control all the flow of your pipeline itself. You can put here different stages. You can define, for example, test. You can define any kind of CI, continuous integration technology or step you want to put in your application. So we have this code to create all of that. I also showed that before, the pipelines itself. So these are pretty simple code pipelines, CDK implementation. But here in the infrastructure is the core of the solution. Here we have all the resources I presented on the diagram. And here we call all of these resources automatically. So we have API gateway. We can create an API gateway with, I don't know, 6 lines of code. We can create an API gateway. We can also use an API definition like Open API spec. So you can create your open API specification, and as 5 lines of code, you can create your API gateway. You also can create a data generator stack. So here we can do all the process to the data generation. We also can create the glue stack. As I mentioned, it's really simple. With 5 lines of code, you can create your glue stack. Your kinesis stack is also very simple. So this is the power of CDK. With small code, with just a few lines of code, you can create everything you need for your solution. Also, Lambda stack. We have here the Lambda stack. You can define the Lambda definition in your CDK. So CDK will create all of these Lambdas during the request. And the network stack. So the core network, the VPCs, the subnet, security group, everything you can create into that CDK stack. And then we have S3 bucket. So as I showed here, it's really simple to create your solution using CDK, because CDK helps you to identify what the resources you need and how you can deliver these resources in an easier way. So let's get back to the presentation. So the data pipeline that this project I just showed to you, let me remind you, was they were really simple code implementations. CDK makes the process to implement solutions in AWS something easier. So other infrastructure as a code languages like Terraform, it's a bit more complex. And as I mentioned, you can reuse your code because you are working with a programming language. So you can export that as, methods, classes, and so on. And the results of that project are the following. First of all, we are able to provide dynamic provisioning of the resources and security roles, changing routing tables without modifying source codes, routing applications. We also had horizontal scaling based off detected messages, backlog throughput with service limit of 400 megabytes per second, out-of-the-box metrics, dashboards about health, throughput of services beyond pod, cluster, system resources metrics, and performance test results that verified routing performance. And we also had fast deployment across multiple regions in new accounts. So just to give you an example, in this solution, we are creating all the resources into a fresh AWS account in something like 20 minutes. So in 20 minutes, you can create everything you see here in a new account. And this is impressive based on the customer past experiences, because just to create a new Kafka, they were expending like 1, 2, 3 days. Now they can build everything in 20 minutes. And all of that, these are some of the performance test results we obtained in the affected routing with 100 subscriptions. We have 2-second end-to-end latency. With the customer old solution, they had about 5 minutes of latency. So now they have just 2 seconds. It's almost, I can't say it is real time, but it is a really fast solution for a data pipeline implementation. With that being said, just to give you some idea, this customer, they have 25 terabytes of data per hour in their work stream. They have a lot of games. And what they wanted was, we have all of these games, we need to filter based on the content of each of these games, and want to give insights from these games to our professionals, to our business intelligence team, to our executive, and they need to get this insight as fast as they want. Because think about that. If with their old experience, they were having a lot of time to process everything. So that kind of message is not enough to create business insights, to help improve the market, to help improve, how we can track the players' activities inside a game. But now they can do that in less than 2 seconds. So they can actually track really fast how the players are, working, how the players are playing, not working. But yeah, you got that. So this was the end solution, some of the results we achieved. And as I mentioned, this solution was a product of AWS Professional Services. So AWS, for games professional services, accelerates business outcomes from ideations and design through, to launch and optimizations. We have solutions for these core elements. In the community and AI ML applications, we can help with personalized game experiences, content moderation, toxicity detection, sentiment analysis, and gamer engagement. And that project, what our customers wanted was just like that. They wanted to detect toxicity and also sentiment analysis to provide better resources and to provide better content, to their players. We also, in the game analytics, we help with advanced game insights, team playing pattern, game performance, and event detection. And in content and media, some of the solutions are related of production, streaming, distribution, contextual advertising, and content localization. And in game servers and network, we usually work with migration, modernization, game production in the cloud, low latency, and elastic architecture for peak and non-peak online play. And, well, for more information or any request, any questions you may have, you can reach me out at any time. So, thank you so much.